Hello dear students, welcome back to the chemistry class and second term. In the last term, we stopped at the discussion of unit number 5, which is the periodic table of chemical elements, lesson number 1 specifically, which was the background of the periodic table. We started with part 1, that was the original periodic table or Mendeleev's periodic table. And today we have the modern periodic table, which will be the second lesson of this unit. The objectives of our lessons today, they are to explain the modern periodic law and describe the different parts of the periodic table. So at the end of this lesson, you should be able to explain what the periodic law is, and you should also be able to describe the different parts of the periodic table. What is the modern periodic law? There is a scientist who is called Henry Mosely, and Henry Mosely realized that when chemical elements are arranged in order of increasing atomic numbers, you can see it here, increasing atomic numbers, there is a periodicity of their properties like ionization energy, like electronegativity. So when you arrange elements in order of increasing atomic numbers, here there is something different from the original periodic law. The original periodic law suggested that the atoms or the elements be arranged in order of increasing mass numbers. But here, for the modern periodic law, we use atomic numbers. So that is the main difference, and the only difference actually, between the original periodic law and the modern periodic law. So according to the original periodic law, the periodicity of properties would be seen if elements were arranged according to the increasing mass numbers. But for the modern periodic law, these elements should be arranged according to the increasing atomic numbers. Increasing atomic numbers, it's here. Can we see that? And that is the basis of the modern periodic law. Sorry, the modern periodic table, I mean. The arrangement of atoms in increasing order of atomic numbers. So you will find that in the modern periodic law table, the one we use today, elements are not arranged according to the increasing mass numbers, but according to the increasing atomic numbers, Z, the number of protons. Elements are classified in order of increasing atomic numbers rather than mass numbers. So we consider the increasing atomic numbers instead of mass numbers, as Mendeleev's periodic table had predicted. So today we don't use the Mendeleev's periodic table. We use the modern periodic table, but they almost look similar with the exception of these two arrangements: increasing atomic numbers and increasing mass numbers. Here we have our modern periodic law. Periodic table. And the periodic table, which has been designed by a scientist called Glenn Seaborg in 1945. So we can say that the periodic table has undergone several modifications through time, but the one we use today is attributed to Glenn Seaborg, which developed this periodic table. The periodic table we use, it's this one, in 1945. And the second part of this lesson, as it had been seen with the objectives, it analyzes how the periodic table, the modern periodic table, is constructed. And here we have the expanded view. You know that the common view of the periodic table it is a compressed view. We have, for example, elements that are called actinides and lanthanides, which are here. We will see them. This part, it is the part of the actinides and the lanthanides. These ones, they are lanthanides because they are all derived from lanthanum. And this actinide, the actinides are here because they are derived from this element, the actinide. And then we have another view here which shows the different parts. We have one part, we will see how it is called. We have another part here, and we have the other parts which are between. Can see them, okay? And the part which is down. So here we can see all the parts of a periodic table, but actually what we have here, this one here, it is a compressed view because between these elements and these ones we have another series of other elements but which are put at the bottom of the compressed form. Now let's see how elements can be classified as metals and nonmetals in the periodic table. See, the elements which are in yellow, these ones, these are the elements in group number 1 and group number 2. Group number 1 and group number 2, these are all metals, except hydrogen, of course. But these two groups represent metals. And from metals, these metals which are very reactive, we have another group of metals, but the metals which are less reactive. And on this part, we have other metals down here which are less reactive. We will see how these three, or the existence of these metals here and the existence of very reactive metals, will affect the name of the metals we have here. And then on the right side of the periodic table, we have other elements which are called nonmetals. Remember, when we say metals, we mean how easy, or the metallic character means how easy an element can lose electrons. And the non-metallic character means how difficult elements can lose electrons. So when we say nonmetals, we mean those elements which can lose very difficultly, and the metals are the ones which lose very easily. Here we have other broad classes of elements in the periodic table. We have the representative elements, we have the transition elements, and the rare earth metals. Rare earth metals are these ones, lanthanides and the actinides. And the representative elements, they are these ones, this group and this group. We call them main group elements. And here we have the transition. These are transition elements. Transition, here it is main, and here also it is another part of main, or the representative elements. And here we have the rare earth metals. You can see the name here. Okay, another way of classifying elements is to group the elements in metals, metalloids, and here you can see we have the metals, the non-metals, and the metalloids. You can see the metalloids, they are these ones on the staircase, and they are in the green color. Okay, these ones in the green color, they are metalloids. Why are they so called? It's because they present both properties of metals and non-metals, so it depends on the conditions. But here we have metals which are present or shown in the yellow color, and the ones which are shown in the blue color, which are non-metals. So hydrogen also is a non-metal. And even these ones, the rare earth elements, they are also non-metals, and we have the noble gases, which have a very low reactivity, or which are almost inert because of the complete shells. You remember that from the electronic configuration of elements. We also have an arrangement which can be based on the electronic configuration. You remember the electronic configuration. For example, you start with hydrogen, it is 1s. When you go to helium, which is next, you go to 1s, but here now we have 2. So you go on adding on what has been done before. When you go to lithium, it is 1s, which is full, but you go on to the second energy level and you add 1 extra electron. So it's like that. When you go to beryllium, it is 2 and 2s2. So you keep on adding 1 extra electron, and that is what is meant by this term inherent, that the electronic configurations are inherent. So you can determine what we call blocks. There is, depending on the subshells which are being filled. For example, all these elements, the subshell we are filling is S, and because of that we say that they are in S block. Here we are filling P block, so P orbital, sorry. So the elements will be in P block, and here we are filling D orbitals, so they are in D block. And when we'll go to the lanthanides, you will find that they will be in F block. So we have also periods. What is a period? Here we have a period. They are these horizontal rows. We call them periods. So hydrogen is in period number 1, lithium in period number 2, period number 3. And here you have to know that a period is equal to the number of shells in the period for a given element. So if an element is in the third period, then it has 3 shells. So we have periods. And we also have these vertical columns. Vertical columns which are called groups or families. Groups or families. And what determines a family is the number of valence electrons. You remember, for the elements, for example, in group number 2, we have 2 electrons on the last shell. Group number 1, we have a single electron. Group number 3, we have 3 electrons, 4 electrons, 5 electrons, and so on. So the number of electrons in the last shell explains the group, or determines the group to which an element belongs. So the vertical columns are called groups, and they are determined by the number of electrons in the last shell. And the horizontal rows, they are called periods, and the periods are determined by the number of energy levels present in a given element. As we said, elements can also be classified in the periodic table according to the blocks. We have S block, to mean that all of these elements are getting their electrons filled in S orbitals. Here we have D block. Here we have F block, as I said, those ones below at the bottom. And here we have P block. Here we have helium, which is also in S block, but because it has a complete shell, we put it in the last group, simply because it has a complete shell. And here we have the last slide, which gives you your assignment. First question, describe the modern periodic law. We have explained it and seen the difference between the modern and the original periodic law. Second question, define a group and a period in the periodic table. What is a group? What is a period? Number 3, an element X has atomic number 32. Determine its period, its group, and the block in the periodic table. So you will determine the group, the period, and the block to which this element X belongs. An element belongs to group number 2 and period number 3. Write its electronic configuration. Its electronic configuration. And you determine its block. To which block does it belong? And the last, but of course not the least, state the two components of F block. The two components which compose F block. The part which is at the bottom of the periodic table. Thank you very much. See you next time.